I like to think it's the unit.
Okay. Cool.
No, it's nice.
All right. So,
Late afternoon.
oh, excuse me. So, last time you guys should have watched the lesson for section 4 that closed up chapter A for us. So the test format should be able to solve, or you have 2 questions where I ask you to solve systems of 2 equations by graphing. I'm going to ask you to include the graph and a table of points that you use to generate the lines on your graph, as well as identifying the solution. 1 question where I ask you to solve a system of inequalities. Remember, we do that by graphing and doing the shading. 2 questions where I ask you to solve a system of 2 equations by using either substitution or elimination. I won't designate which one you have to use. You're welcome to use either. I have 2 story problems that are basically, you end up having to write a system of 2 equations to solve it. I have 1 question where I ask you to solve a system of 3 equations by substitution or elimination. Again, your choice. I won't designate what you have to do. And then 1 question where I ask you to write the general solution for a system of 3 equations that has infinitely many solutions. Do you want to do examples of anything here from the list? I have a story problem example queued up and ready to go. Should we do that?
Yeah.
All right. We'll start there.
When does our no clip due?
Today.
What? What's the first hour of the test?
Let's worry about this one right now.
When is the review due? Is it due this Sunday or next?
Let's worry about this one right now.
It's a joke. Oh my God.
At a bake
I
sale,
have no cardinal.
cookies are sold for $2 each. Brownies are sold for $3 each. A total of 25 items are sold together. If the money made from cookies and brownies is $65, how many cookies and brownies are sold? The first thing I'd want to do is I want to identify what the question is asking for. So if you read this, what is the question asking you to find? Great. So those will represent our variables. So C is the number of cookies sold, B is the number of brownies sold, right? Everybody's happy with that? Okay. Now let's go through and identify some of the other information. So the first sentence, it says cookies are sold for $2 each and brownies are sold for $3 each. What is that $2 then? What is that representing? Nope. What is that $2? That number 2 means something. What does it mean?
How much the cookies cost?
Price per cookie, right? It's a rate or the cost per cookie, whatever. And what's the $3 then?
The cost of the brownie.
Yeah, price per brownie.
That's what I meant.
Okay. So the next sentence says a total of 25 items are sold all together. When I hear all together, What mathematical operation should we be thinking about? Adding. Great. So we're adding two things, and that should give us 65, right? Because it's 65 altogether. What two things are being added to get to 65?
C plus B.
C plus B. Everybody feel good with that? Okay. So the next sentence reads, if the money made from cookies and brownies is $65. Okay. So we have the money from cookies plus the money from brownies has to equal, oops, that was, I misread, that was the 25, and this is 65, right? Everybody's okay? I'm now going to take this equation that we've written in words and translate it to symbols. So how do we get this money from cookies? Okay, well, that's $2 per cookie. That's not just dollars, right? How do we calculate the money from cookies? If I've sold, say I sold 8 cookies, how much money should I have generated from those cookie sales? 16. How'd you come up with that?
It's double.
2 times 8.
2 times the number of cookies sold, right? Now, how about the money from brownies? How are we going to calculate that? 3 times B. The price per brownie times the number of brownies sold. So the system I have then is, yes, a total of 25 items are sold altogether.
So why did it change to 65?
Because the next sentence says the money made from cookies and brownies is 65.
So is it a different equation?
Yes. As soon as I read that I have 2 variables, cookies and brownies, I'm going to have 2 equations. Is everybody okay how I translated the words to the system? To solve this system, how would you like to do that?
Substitution.
Sure. To do substitution, what are you going to do?
B by itself?
In which equation?
The first one?
Okay. To get the B by itself, what would we have to do? Subtract C from both sides. Okay. So B has to equal negative C plus 25. What do I do with that now? Okay. So I'll distribute the 3. I'll combine my like terms. Subtract 75 from both sides. And divide by negative 1. I have C equals 10. So 10 cookies we sold. How am I going to find the brownies now?
C,
That
C,
the other way around.
solve for B.
How about I just plug it in there? Since the B is already by itself. So 15 brownies. That feel okay? What do you guys want to do next? Do you want to do another? You do something else?
Go up.
Yeah, of course I can go up.
Because what we just did was store a problem in the system of two.
Yeah, yeah,
We will system of three. I
sure.
just don't know.
Okay. Do we have a preference, substitution or elimination? I think elimination is much easier to do in general, so I'm happy to do that. To start elimination, we need to choose a variable that we wish to eliminate. So it's a choice between x, y, or z. I think any one of them is okay because there's an easy choice to use as an eliminator equation for any variable, since each equation has a coefficient of 1 somewhere in it, or each variable has a coefficient of 1 somewhere. So let's say we're choosing to eliminate the x's first. So I'm going to refer to these as equations A, B, and C. If I want to eliminate the x's from equation A and equation C, what do we have to do so that when I add those two together, the x's will cancel out? Great, so we'll multiply equation 3, or equation C by negative 3. So equation A, I'm going to leave unchanged. And then equation C, we're multiplying everything through by negative 3. So when I add that down, I end up with 13y minus 11z equals negative 77. So far, so good. Now, I'm going to eliminate the x's from equations B and C. What do I need to do to eliminate the x's from equations B and C? Okay, so I'll do B plus negative 6 times equation C. So I didn't do anything to equation B. And then we'll multiply equation C by negative 6. One, or no, yeah, 174, I think. So when I add down, I get 26y minus 19z equals negative 172. What do I notice here? I'm going to call these two guys my new equations D and E. What I'm left with now is a two-variable equation, right? So again, I'm going to either use substitution or elimination. I'm going to use elimination again. Which variable does it look like it will be easier to eliminate, y or z? Y. How are you going to do that? Negative 2 times equation D plus equation E. I got to make sure they're opposites. And then equation E, we're choosing not to do anything to at all. So when I divide by 3, I get negative 6 for Z. God bless you. You're welcome. Now that I have one of my solutions, how do I find the next one? Where? Not anyone. Any two-variable equation. So D or E. Does it matter which one we plug into? Nah, I'm going to, for the sake of argument, I'm going to plug it into D. Is everybody okay there? And now how do I get my final piece? My x, I'm going to plug both of those back into any three-variable equation. For the sake of argument, I'm going to use that first, or equation 3. So my final answer should be 3, negative 11, negative 6. That's kind of the convention. Straight at X, Y, Z. Just in alphabetical order. Is it wrong if you don't? No. But typically you would. Does that feel okay on walking through that? The pace was okay. I tried to go pretty slow and explain what we're doing. So what did we do? We did this and we did this.
General solution.
So if we have a problem where there's infinitely many solutions, grab a question where that happens. Double check real quick. Good, I thought that was the case. So let's look at this one. So let's say we choose to eliminate the x's first. Again, I'll refer to these just as equations A, B, and C. Well, I can just add equations A and B together the way they are. And the x's will cancel out because the x's are opposites, right? Everybody feel okay there? And then I'll do, say, 2 times equation A plus equation C. So I'll have 2x plus 10y minus 4z equals negative 2. Negative 2x minus 7y. 3z equals 7. 3y minus z equals 5. Refer to these as equation D and E. What do you notice here? They're the same equation, right? They're literally the exact same. Well, what does that mean? It means if we subtract them, what are we going to get? We'll get everything to cancel out. That is our, not all real numbers, that just means infinitely many solutions. Now what we'd like is we'd like the general form of those infinitely many solutions. So when we have infinitely many solutions, what we're going to do is we're going to pick one of these 2 variable equations. Well, in our case, they are the exact same, so it doesn't really matter. And I'm going to choose to get one of these variables by itself. Which one looks easier to get by itself, the z or the y? Z. Because I don't have to do any division to get the z by itself, right? So I'll subtract 5 over and then add z over. And I have that. So my general answer the z component should be 3y minus 5. because we've written our answer in terms of y, my y component is just going to be y. To figure out what my x component should look like, I'm going to take my answer for z and plug that back up into any of the 3 variable equations. For the sake of argument, I'm going to plug it into the first one. And then in place of z, I'm going to write 3y minus 5. And now I'm just going to get the x by itself. This should be an expression in terms of y when I do that. So I'll distribute the -2 through. Combine my like terms. And then I'll subtract over my 10 and add over my y. And I'm left with x is y minus 11. So there is my general solution. What this general solution allows you to do then, if I wanted an answer, say, okay, this has infinitely many answers, great. Does that mean I can pick any 3 numbers and it's going to be a solution? Well, of course not. But what this allows me to do now is it allows me to pick a y. So pick a y, a number for y. Somebody, to shout out a number. 5. If y equals 5, then x should be 5 minus 11, or -6. And z should be 3 times 5 minus 5, or 10. So one of my infinitely many solutions would be -6, 5, 10. You guys kind of see what I can do with this? And since I have infinitely many choices for y, I get infinitely many solutions generated, right? AJ? Yep. Does that feel okay there? Again, relatively easy thing to do, but you want to practice, right? Takes a couple of tries to feel good about that. But it's not much different than the normal process, just when you get 0 equals 0, you have some extra stuff to do at the end. It was on the list. The last one. Okay. Today, we also need to get our homework quiz done. So if you guys clear your stuff, we'll do that here.
Tomorrow, before. You can turn in the fact sheet on OneNote, right? And then you can put it together.
No.
Oh, no.
You can email it.
Oh, you can do that.
But I'm not print stuff from them.
You are?
When is our homework?
In my bag is something like.
How's it
It's
going?
amazing. I don't want to talk about it. Don't be comfortable play that.
I've got 3 questions here.
Can I borrow a calculator?
Do you have enough for any change?
Half sheet, do you have?
Can I borrow a calculator? In the back.
You can take that red one.
You think you can take? Can I take this one?
Do you have any other calculators or no?
I do not. So, like, you guys keep acting surprised about the half sheet stuff. I would remind you guys that, like, every day or every week on Monday, I write out the agenda for the week. Like, it's been sitting there on my Notre Dame, you know, like the whole time. You know, like, I do expect you guys to look at that kind of stuff. So make sure you're reading the directions on the problems. There are some instructions on how I'd like things done.